Space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the road to the chemists, but that's just peanuts to space. That's Douglas Adams in his noteworthy science fiction classic, The Hitchhiker's Guide to the Galaxy. We so often don't think about how we would traverse outer space because, like our oceans, except on a much grander scale, so much of it is still unexplored. So how does one get around? On July 13, 2019, a Russian state corporation known as Roscosmos launched Spectre-RG, a space observatory carrying the eRosita X-ray instrument, as well as the ART-XC space telescope. A cooperation between Russia and Germany launched from Baikonur, Kazakhstan. Spectre-RG was to complete a 6-month halo orbit around the Lagrange point L2. In 2019, it began a 7-year voyage to image the entire sky in the X-ray band. eRosita is expected to detect 100,000 galaxy clusters, 3 million active galactic nuclei, and 700,000 stars in the Milky Way, and data is still being reviewed. Science hoped to measure dark energy through the structure and trace the history of the universe through galaxy clusters. On October 17, 2019, it achieved first light and completed its first all-sky survey. On June 11, 2020, in the summer of 2021, the first eRosita X-ray data released to the public was announced. They had learned so much of the universe in a new wavelength. The operations of eRosita were suspended on February 26, 2022, after the Russian attack into Ukraine. The science operations of the instrument were paused, but the analysis of the data already received in Germany continued. At that time, eRosita had completed 4 of its planned 8 full-sky surveys. In June 2022, Roscosmos announced its intent to restore the operation of eRosita unilaterally, which was criticized by experts for its potential to damage the telescope. The first all-sky survey was completed on June 11, 2020, cataloging 1.1 million sources, including mostly active galactic nuclei, stars with strong magnetically active hot coronae, and clusters of galaxies, but also bright X-ray binaries, supernova remnants, extended star-forming regions, as well as transients such as gamma-ray bursts. The map includes extended features of the Milky Way, including mushroom-like bubbles and absorbing galactic gas in the disk. As recently as August of 2025, scientists studying data collected from eRosita concluded that there are interstellar channels between distant stars. These channels cannot exceed the speed of light, and they offer little room for living creatures, as inside them, temperatures and pressure can get too high for survivability. But what if you existed in a quantum state? A quantum state is represented by a wave function, particularly when they are functions of position or momentum. What if your particles were in flux? If a creature managed to exist in such a state, traversing these interstellar tunnels as well as quantum tunneling, where particles like protons and electrons, and sometimes neutrinos, pass through energy and matter barriers and cease to exist in the middle of those barriers until they appear on the other side. As of this year, nothing I have read says that scientists definitively know where they can go from one side of the barrier to the other, or where they go when they're in one side of the barrier to the other. So what if a multiverse exists and they go there when they pass through things? It's like the classic thought experiment of Schrödinger's cat. What if a quantum particle in between the walls of a barrier both exists and doesn't exist simultaneously? In 2022, I wrote a book called The Golden Age of Man, where I posited that traversing space was possible if you did it in a quantum state of pure light and energy. From these findings, it appears that I may have gotten some things correct. In review, quantum particles are unaffected by heat and pressure, making traversal through interstellar channels a possibility. Black holes are black because even light can't escape them. But what if white holes, which are only theoretical now, exist on the other side as a fountain of light that can't go back in. If our universe has shown us that connection is so important that interstellar channels exist, why couldn't other avenues be open to beings in the right state of flux to access the pathways to it? Perhaps the universe has shown proof that there are ways to travel between stars, and existing in a quantum state, or a state of flux, will be the way to walk the road to Valhalla, the kingdom of our vast and ever-expanding universe. I'm Dylan Paul for Professor Shank's astronomy class, saying I hope you have a wonderful day. And like science fiction writers and scientists alike, keep dreaming of ways to travel the stars.